17 and Gauss go together for mathematicians and are kind of symbol of the cultivation of youth and the success of youth in mathematics that MSRI cultivates so strongly. The Space Lab, our neighbors on the hilltop, always wanted a real street name and a real street number. I thought it should be named after some famous scientist. But who, given that it's a space lab and a math institute? Well, Gauss, I thought, might do. Gauss was one of the greatest mathematicians of all time, and also, incidentally, the director of the Royal Astronomical Observatory in Germany at that time.
The Mathematical Sciences Research Institute in Berkeley, California was founded in 1982 by three Berkeley professors, Xingchen Chen, Cal Moore, and Isidore Singer. They envisioned a place where mathematicians could gather for intense periods of communication, collaboration, and contemplation.
MSRI started its life near the campus in a temporary building, but it was a part of the design from the beginning that MSRI would have its own building. The location was one of Cal Moore's master strokes. He saw an ideal piece of property, a very idyllic setting, very beautiful views, and grabbed it for MSRI.
The university held a design-build competition for this building. Ours was the only building in the competition that had the appearance of a large house and was clad in wood. All of the other submittals were clad in stucco.
He was chosen as architect, and the building went up. He was particularly good at collaborating with the mathematicians, and there was a very intense back and forth between him and Cal Moore. Singer and Chern, who were the triumvirate, were mostly responsible for the institute.
We don't start with an artistic idea, we start with problem solving. We attempt to bring a level of craft to the work. What I enjoy most is getting a real understanding from a client of what it is they want and finding a way to make that happen for them.
For me, MSRI is really a place where mathematicians come together to exchange ideas, to learn new techniques, to train young people. The heart of what we do is bring people together and form communities.
There was a requirement that common spaces for informal meetings be dispersed throughout the building. Our response to that was to arrange the offices and the informal meeting spaces around a three-story atrium. We referred to that arrangement as a social network in which if you left your office, you would be able not only to see everything going on within the building, but you'd run into your colleagues. There was an opportunity then for informal meetings, discussions. The common spaces that we dispersed were open common spaces with chalkboards and places that people could just pick up a piece of chalk and start writing on the chalkboard.
The brilliance of the atrium is when you take a double-loaded corridor building and you widen the corridor and make it open, not only do you bring light to the bottom, but you allow people to come out of those offices and see what kinds of activities are going on. The atrium was a stroke of genius.
It was clear in the program issued by the university that they wanted to capture the views of the bay, so that when you walked into the atrium from the entry court, you were looking directly at the Golden Gate Bridge. We aligned the center column line of that entry lobby with center span of the bridge, and the surveyor came up to lay the stakes out for the rough grading. It's foggy, and you can't see the bridge. And I get on the phone to the contractor and I said, you know, your surveyor's up here. He can't see the bridge. He's working from his notes. Don't worry about it, he says. If he misses, we'll move the bridge.
The building did very well and was considered a kind of model for such things for many years. The open atrium, the cave-in commons design, these were hallmarks of MSRI. But there were some real problems too. And in a way, one of the problems was the very success of MSRI, which grew much faster than people dared to anticipate when it was first built. And with a lot of people flowing through, now more than 2,000 visitors a year, the old building simply wasn't adequate. There was one auditorium. It was small and oddly shaped, and indeed the idea of extending the building had been in the minds of my predecessor and my predecessor's predecessor, both Bill Thurston and Irving Kaplansky. So our architect, Bill Glass, had been influential since the very beginning. He was, of course, the architect for the original building. People were very happy with how that came out, and also, not trivially, with the interaction that he'd had with the mathematicians.
We never start with a preconception of what a building is going to look like or how it's going to function. It all comes out of the process of working through the design with the client. The Institute went about forming its own building committee. We would usually show them different ways of approaching a problem, solving a problem, and get some feedback from them about what they liked best.
I myself and many other mathematicians involved in the project had very strongly the feeling that we designed the building. Bill was just an adjunct to this process, although I know well that that's not really true.
Any site that's western exposure in the Bay Area, that's a very difficult exposure. It's very hilly. The soils around here are not all that grand. You get a lot of wind up here, which is another reason why I think the L-shaped entry is so important now, because it really gives a protected area, which made a much more gracious entry sequence, where we have the outdoor court, and then they have a real lobby with a pretty grand staircase. And as you pass by these spaces, you see other public areas. You turn left and there's auditorium, you turn right, you see the public space and the big view. So there's a lot happening at that connection, which didn't exist in the original building, and I think it's much more powerful now.
As we began to think about the siding of the auditorium, we looked at the concave or the saddle portion of the site, and it makes a sort of natural bowl, a natural stadium shape, which allowed us to capture both the form of the auditorium in that convex landform and take advantage of the landform for the slope seating. The auditorium, which was the missing element in the original building, is designed to accommodate mathematical presentation, but also designed to accommodate performances by small musical groups.
There are lots of mathematicians who are very good musicians and very interested in music, and we wanted from the beginning to have a space that could be really effective for musical performances.
The auditorium seats with fixed seating 135, and with temporary seating we can get close to 200 people.
The blackboard system is very important in a mathematics auditorium. Mathematics is one of the few disciplines where really long, intricate arguments are presented, where one step of the argument builds on the next, where definitions are sharp and crucial. You have to pay attention and know what happened in the first part of the lecture to have a chance of understanding what's happening in the second part of the lecture. This is hard to do when the material goes by and disappears. In a good mathematical auditorium, there are 6 blackboards, and by the time the speaker gets around to erasing one, all 6 have been filled and 5 remain. That's quite a long record of the talk. It also is a very positive thing that the speaker draws on the blackboard. Somehow the audience sees the speaker thinking and gets a sense of the thought process. There's a much more direct personal engagement, which I think facilitates learning very strongly.
Here and throughout the rest of the building, all of the boards are chalkboards. Mathematicians do not use whiteboards.
The feeling of chalk on the blackboard gives a kind of physical reality to mathematics, which is very pleasant. The sense of chalk is really a part of the history of mathematics in some deep way. For a while we had a journalist in residence program that I liked a lot. And one of the journalists told me and wrote in one of his pieces that we were the only community that still used dead diatoms for communication. Chalk is really a standard medium for mathematicians. Sitting in the auditorium listening to lectures is very important to us. There are lots of things that often go wrong in math lectures that architecture can help fix. For example, people tend to sit in the back of an auditorium. They're a little disengaged, a little diffident.
The layout of the auditorium is such that when you are entering the auditorium from either the main level or the balcony, there's a generous amount of space at the back of the auditorium that allows you as a member to come in and sample a lecture.
They can come and they can spend a few minutes and they can decide whether this is something that engages them and they want to commit some time to it, or they can leave. That's really the nature of this place, is you can choose the kind of interaction you want, how public you want to be, or you can retreat and do your private work.
Another goal was to get members coming to a presentation when the auditorium is not full to come to the center front of the auditorium. We've all been students. We all know that when you come into a lecture hall, you go to the periphery, you get as far away from the lecture as you can. Here we tried to get the members to come in, sit down up front, so that when there was a smaller group, there was a more intimate relationship with the person giving the presentation.
We made the first 3 rows extremely comfortable and attractive. The desks were a big plus. So we designed the auditorium to try to take these human factors very much into account and to improve the interaction. We put the speaker below the audience so that the figurative version of being below the audience would come into play. The audience has solid desks to sit behind. The speaker looks directly out at the eye level of the audience so that there's a very strong connection.
The balcony, which is supported off the back end of the auditorium, is also supported on steel cables which hang from the upper part of the wood beams as they approach the rear of the auditorium, and the struts that you see when you're up in the balcony come right to the support point of those steel cables.
Acoustics are also very important. We have a big room. It's meant to accommodate both medium-sized seminars, 30 people perhaps, and lectures of 200 people. If the speaker feels that he's talking to an empty cavern, then he strains his voice. If the audience, on the other hand, can't hear him, that's no good. If you need amplification to hear the speaker, then there's another layer of disconnection. There are big wooden panels that cover the blackboards, which reflect sound well, and many features of the auditorium, the curvy roof, for example, which, by the way, was entirely Bill's idea.
We designed the auditorium so that lectures and musical performances both could be accommodated without electronic enhancement. The materials, the selection, the forms of the backdrop of the auditorium, the ceiling shape, the convex scallops, they're designed to distribute the sound evenly in the auditorium, and then at the back of the auditorium are more absorptive materials so that the sound then doesn't bounce back and focus back to the speaker. Another thing that was really important to us was bringing natural light into the auditorium. So all around the periphery, at the back of the auditorium and in these great north windows, we bring natural light in. The auditorium on both the north and the south sides opens directly to exterior space. We have the Birla Camp Garden on the north, and on the south we have the Strauch Outlook.
The decks are ways really of getting out onto the landscape. We celebrate on them, we go out to pace up and down on them and think about mathematics, we go to sit and have lunch. Inside Outside was a slogan of mine with the building, and we tried to do that throughout. People spent a lot of time sitting in the lecture hall. It's so nice after that to be able to just walk out through the big doors into one of the outdoor spaces. One of them is the Birla Camp Garden. In the spring, it's perfectly gorgeous with flowering trees. It has a nice outdoor blackboard. That was something I wanted very much for the Institute.
The nice part about this building is there's so many interesting parts about the outdoors, with the eucalyptus on one side and the big view on the other, and the sun that goes all the way around it because of the way it's oriented. All of those things are connecting people to the site all the time.
It was very important to have a generous seminar room, which also doubles as a boardroom. This is the Baker Boardroom, and it's designed to accommodate seminars of 40 to 50 people comfortably. So the tables you see are all modular tables, custom designed and built. They can be rearranged as they are now for seminar use. They can also be arranged as a very large single boat-shaped table to accommodate the board meetings. There are 17 sides to the table. The address of the building is 17 Gauss Way. That theme repeats in a number of different places in the building.
The Kalman Room serves a very important feature. People do go there by preference to the atrium for smaller events, for more informal sitting. There's blackboards, of course, where you can work there. That's very convenient. And there's the possibility of going out onto that nice deck outside, though even the deck up in front of the Common Room is more contained than the other decks in the building.
Will Hearst named the library for his mother, Austin McDonald Hearst, and was generous enough to give us funds to provide a new level of finish in both the old and the new portion of the library. The library is a non-circulating library, but it is open. So members of the Institute come in, they find a book, take it to the light, sit at one of the little carrels by the windows.
The library has a sense of restrained and quite quiet comfort to it. It has good leather furniture, it has beautiful tables designed especially for it, it has lots of windows looking over the views. It has a sense of containedness, but also a sense of openness, which plays very well with the inwardness that mathematicians have about what they do, and the sense of, nevertheless, looking at the great landscape of mathematics.
In the expansion portion of the library, there is an opening in the ceiling, which picks up on the 17-sided polygon.
17 is the number of sides of the regular polygon that Gauss discovered really could be constructed. The ancients knew how to construct an equilateral triangle, a square, a pentagon. If you can construct an n-gon, then you can construct a 2n-gon just by dividing all the sides in half. But nobody knew whether you could construct a 17-gon with ruler and compass. This is actually not a problem in geometry, but a problem as Gauss interpreted it and solved it in the theory of equations. And this solution, which he made when he was still a teenager, really put him on the map mathematically. It was his first big splash. So we recognize that and remember it in the street number 17 Gauss Way. Mathematicians have such wildness inside that a kind of subtlety about the outside, a containedness, a quietness of the environment, immediate external environment, is a very positive thing. The flights of fancy come in a different way in mathematics. On the other hand, the vistas and the landscapes, the long views, really do, for me, represent a side of mathematics, which is concerned with the larger view of science, the fact that one piece of mathematics applies to many parts of science. Somehow these come together for me in the big views of the landscape that MSRI features.
I think this building is a perfect reflection of Bill Glass. Not everybody would have done all the things that he did here as a way of connecting this place to the campus and to the environment and to its hillside and to the light. All of those things, I think, are really masterfully handled.
What I'm proudest of about this building is that the users really seem to enjoy it. They like the atrium, they like having their teas, they like the use of the auditorium. I get pleasure coming up here and just seeing people using the building, enjoying the spaces that they're in.